Yeah, welcome back once again to my channel. Today I'll be talking more about the BQ chip, and I'll be using a Lightbook, a HP ProBook 4400G4. It's a quantum board. This board is a quantum board. Before we get started, my channel, as I'm new to YouTube, it motivates me to see how my subscribers count are increasing. I'll be glad for that, and always turn up the notification bell. We are still working very hard to see how we can be able to get a very good audio output that will help, and I believe that every day by day the audio is getting better. Now let's get started now. Before we can be able to talk about the BQ chip, before the BQ chip can be able to get his his power. Now this is the DC jack. This is the adapter input here. This adapter input pin 1 and pin 2 are the positive line that carries the voltage, while 3, 4, 5, 6, 3, 4, 9, 10 are grounded. You can see the LED is coming from the 5-volt area. This one also is a LED. This wireless LED, audio LED, all this. But this is what we want to talk about, the plus sign. We have a 19 volt coming to this particular place here. Here we get, when you come with your multimeter here, you get a 19 volt at that point in time. You get a 19 volt at this point here. If you test it very well, you get a 19 volts here. Then now the 19 volt pass through this coil. Those two coils has 19 volt also. If you check it, has 19 volt. Then from the 19 volt also pass through down to this Zener diode. You can see close to the diode, away from the vein, this Zener diode. From the Zener diode, it now pass through to this first power transistor. Yes, let me say this is a transistor also, but this is an N-channel transistor, because you can see that the diode is connected to the drain of this transistor. Here you get a 19 volt also. Here we also have a 19 volt. We also have a 19 volt here. We get the 19 volt here. This input here is 19 volts coming through the drain. Here also is 19 volts. Now pass through to this second. This is a MOSFET, to the second MOSFET. To the second MOSFET, you can see the drain, the source here is carrying 19 volts. 19 volts. In 19 volt. 19 volt pass through this MOSFET here to give a 19 volt here also. Now from this part in time now down to this current sensor. This current sensor here is the current sensor, carries 19 volts. If there is any shorted capacitors on the motherboard, this current sensor will not carry any voltage. Here we read a 0 volts if there's a shorted on the board, here will be 0 volts. Otherwise, you have your 19 volts here. Use your 19 volts here. Then we head into the main power array. This is the main power array here. But we are not discussing about the main power array. What we want to discuss about is the BQ chip. This is what I want to discuss about here. I want to give more light on this particular chip. Now, and the most voltage required for this chip to start very well. Now, as you can see, this is the BQ24, let's say 24780SRUYR, and the working principle here is nothing difficult. If you can go through the data sheet of this chip, you will see that the working principle is very simple and is the most common charging IC used by most laptop manufacturers. Most of their brand use this particular chip. Now, the first thing we're going to see here is the VCC. This VCC. The VCC is coming from this dual diode. Here is coming from this voltage coming from the battery, the adapter voltage. Here is coming from the adapter voltage, and here is coming. This other one is coming from the battery voltage. This chip has a very good has a very good role to play. As you can see, if the current is coming from the adapter, this one will enable the chip, and if adapter is not present, this other one will enable the chip. Then this one used to be 19 volt, and this will be the battery voltage. I think it's around 12 volt also. Now, when we have this two, then the VCC, we are getting a 19 volt VCC. Yeah, we're supposed to have a 19 volt on this 19 volt. Depending on the adapter that is carrying 19 or 20 volt, depend. Now, we already have the 19 volt from the VCC. Now, the next thing we are going to look about after we have our VCC, we'll look at the AC drive. I get my point now. We're going to look at the AC drive. This drive, this MOSFET here, let me drop this. This is what we want to talk about. This guy here, this man. And this is coming from the gate of the second MOSFET. The first and second MOSFET gate is coming here because it's driving the first and the second MOSFET gate. And this, what is it called? This voltage here is supposed to be higher because this is an N-channel MOSFET. The gate carries a lot of volts to open this MOSFET. This will be around 24 to 26 volts. This here is supposed to be around 24. Let me see. It's supposed to be around 24 volts. To 26 volts. That's how it's supposed to be. Then the next thing now we'll talk about here is the AC OK. Here now, if you trace it up, we have one resistor here, one other resistor here. By the time we use our current, what is it called? Let me try something. Let me use the calculator and see if I can do that math real quick. Yes, 19 volt is coming in times 249 will give us what? Will give us 4731. Then the first resistor is 2. Then we are getting 249 plus 40.2 is giving us 2. Then we have 4731 divided by 289.2. I'm not sure this is giving us the AC dictates. The AC dictates supposed to be around 2.6 volts. It's supposed to be 2.6 volts. Yes, no, it's supposed to be 2.6 volts also. One sec, let me see something else. Panel is coming from 19 volts. The other one is 0.2. Give us this divided by 289.2. 2.6 volts, sorry. It's 2.6 volts. AC dictator, this is the R1. This is R1. The first resistor. And this is the main power, 19 volts. You know the formula for first resistor all over first and second resistor plus divided, you give it the voltage. Now this is 2.6 volts. I get a 2.6 volts here. Where is it? 2. 2.6 volts. How we are getting here. Then the next one is ACOK. The ACOK is coming from 3.3 volts. As you can see it here, it's coming from 3.3 volts. I see it. ACOK and AC dictates. AC ADP dictate, adapter dictate. It's coming from 3.3 volts. Here will be 3.3 volts. Here is 3.3 volts. Then we are looking for another important pin. Let me see which other important pin is here. Reg. This reg is 6 volts. As you can see, it's indicated there is 6 volts. This is 6 volts. Then this is the high drive. This is driving this MOSFET. This is driving the gate of the first MOSFET. As you can see it here. I see it. It's driving the gate of the first MOSFET. Then the lower drive, the lower gate here, as you can see them. And this is phase. This phase is sensing the current that is coming from the source of these two MOSFET, the source and the drain of these two MOSFET here, to produce the output voltage of the current sensor of the battery connector from the battery side. You get out to plus bat charging. You can see and look at the two current that is coming from the current sensor, SRP and SRN. Both of them will carry the voltage of the battery. The voltage of the battery is both of them will carry within the bit drive. So it's driving the BQ batch driver. Let me check again and see. We talk about the rest. This ACP and ACP and ACN, they are coming from the current sensor. Both of them are 19 volts. Both of them are 19 volts. Both of them are 19 volts. And let me see again. What other chip is required here again? I will need to talk about. Let me see. This SDA and SDL are coming from the Super IO. They are 3.3 volt. Both of them, they are 3.3 voltage. They are 3.3 volts. I'm trying to see if there's any other. This BTST in some schematic is written at as boost. Boost is also coming from here. The same voltage with the phase voltage. It's very important you check for that voltage also. Then the last I forget, the SMSRC voltage. Is a voltage reference. This is a voltage reference. This CMSRC voltage reference is coming from the source of the first and second MOSFET. If you trace it up this B pad, you can see the source of the two MOSFET. That is it. It's 19 volt also. You can see it here. That is it. Then I guess that is the most important pin out that is required. Then this is the tune start. Also this tune is coming from 3.3 volts. Lest I forget, sorry. Tune, that is SB start. It's coming from the 3.3 always. You can see them. These are the basic requirements required for the BQ chip to function effectively. And after the vein of this MOSFET, this is the main power array. This is the main power array. From this place, 19 volts go all over the board. All over the board. Then all over the board. Please don't forget to subscribe and like my video for more. Please comment which other IC you want us to talk about. The next IC I will be talking about will be 3.3 volt and 5 volts buck regulator IC. That will be the next video I will be uploaded soon. That is the next video I'll be uploaded. Please like and subscribe to my channel for more video. Thank you.